everyone, just Mr. Tukin, and wanted to go over this representing functions tutorial. When we're looking at representing functions for the design, we're just going to focus on three different things when we represent function. We're going to talk about function notation. And just so you know, I got a quick example here. Function notation, to be honest with you, it's all are the same function. Everything you're looking at here is 2 times some variable plus 3. Yet there's a different name for it. And in fact, there's a different input variable, but they're all the same function. They just have a different name. This would be function f, this would be function g, this would be function h. And then we would describe it as f of x because it's our input. We're function f representing x, g of x, h of a. So all the same functions, different name. We're also going to talk about domain and range. And when you hear the word domain, you need to think about x, or it could also be your input. So like in h of a is your domain. It's the values that a can be, because it's your input. It's what you're inputting into the function. And then the function h in this case is what the function equals when we have a value for a, or it's what g of x equals when we have an input for x. And then range, similarly, is all about the y's, or what the function ends up equaling. It's your output. So you input a value, that's your domain, and then what does the range, what does the y end up equaling? So if x is 5 and y is 2, well, that's our input output. And then we're also going to talk about when is a relation a function. We'll show you that in a little bit. It's going to definitely help. There's two different ways that we kind of talk about vertical line test. Probably won't do that here. However, we're going to talk about do the x's repeat. That's going to be the big thing we're going to do to quickly determine if a relation is a function. Now, like we talked about when we're representing function, we're talking about function notation. What used to be a linear, in this case, a linear equation, is now a linear function simply by replacing the y with the name of the function, f, and your input value. So the input value is the value we throw in, and the output value is when the x is 2, what does this side end up equaling? And let's see that in action. So when we have a statement like this, you'll get a function, something like this, and then they'll say, what is f of 4? So literally what they're saying when they say f of 4 is instead of that input variable, we now have a value instead of the variable. And anywhere that there was a variable, we plug that number in and we just do the math. So in this case, f of 4 ends up equaling 3 times 4, which is 12. So we're doing a little order of operation. And in this case, f of 4 ends up equaling 13. You'll also see this is how we get our ordered pairs. This is how we graph the function. So when x was 4 in this particular function, y was 13. So when you see like the graph of f of x, and suddenly there's a point at, let's say this is 4, and up here is 13, and there's a dot, that's because when our input was 4, our output was 13. Now I know we just input it into the actual function, but you'll actually get questions like this. You'll get questions that say, hey, use the graph to determine the correct numbers. So I guess we're saying this is a function g, because our function notation has the variable g. And instead of being given the actual function, we're just given this graph that's supposed to represent the function. And we've got those dots that represent ordered pairs. So they're asking us, using this, to determine what each of these end up equaling. Well, remember, we've got our inputs and we don't know our outputs. But remember, what this is saying is we know it's -2 for the inputs, or most kind of, we'll usually say it's the x. So our input's -2. Well, when x is -2, remember this is your x-axis. When x is -2, what's our y? Well, when x is -2, we find that this is the dot, and that's at 2, 6, -2, 6, excuse me. You can pause the video and try to answer these other two, g of 3 and g of 0. So exact same situation here for g of 3. We want to go to where x is 3. So I've gone to the right 3 spots. And then I find that point. Ooh, it's right there. It's at -4. So when x is 3, when our input is 3, the y value is -4. And same thing, if you want to pause it, go ahead. But when x is 0, well, we're just looking. Okay, x is 0, which means I'm not going to the right. I'm not going to the left, because that's our horizontal axis. That's our x. And lo and behold, ooh, -5. So we've got this -5. Now, when I mentioned the vertical line test, if we're trying to determine if something is this is going to be the worst connected the dots ever done. But if we connected these dots, you could see that it doesn't, if we were to pretend there was a line, let's say they asked us another question, hey, is this relation, is this a function? Well, if we were to move this line anywhere along this, notice how it would only touch the blue line one time. And if that's the case, it actually is considered a function. It passes the vertical line test. However, as we move on, we're going to talk about domain. And again, that's the X or the input. So when we talk and you hear the word domain, it's saying, hey, what are my values of X? What can my inputs be? And then similarly, we've got that connection with the range. It's equal to our Y values typically, and it's our output. When the domain is this, what is the output? Or here are all of my domains. Here are all of the corresponding ranges. So we've got something like this. So when we write, the 0.35, we're saying we have a domain of 3, okay, or our X, our input, and when X is 3, our output or our Y is 5. So keep that in mind. That's your input and your output. When X is this, what is Y? So when we have a domain of 3, we have a range of 5. But shifting gear, you'll get these big, long statements that say, hey, I've got this relation. What is the domain? So here's the only trick here. When they ask you for something like this, you just list all of the X's or inputs, but remove the duplicates. So if you have any duplicates, get rid of it. Okay, if you have any duplicate X's, we just get rid of it. And you also should probably put them in order. When I say order, I mean from least to greatest. So if you're looking here, if I initially just write them all out, I've got 3, -5, 3, 0, and 6. And then just, I'm literally grabbing all of the X's, all of the inputs from each of these ordered pairs. But as you can see, I've got a duplicate 3. We would not list it twice. So from least to greatest, I'm going to start with that negative number, -5, 0, 3, and 6 would be the domain here. And guess what? Exact same thing happening for the range. The range, as we just talked about, is our Y values. It's our outputs. So same idea. We're going to grab all of those Y values and we're just going to list them out here. So I'm going to write 5, 1, -2, 4, 8. Now maybe you just say, hey, I'm just going to go straight to in order. I don't have any duplicates, so I don't have anything to remove here for the range, but I'm going to write -2, excuse me, +1, 4, 5, and 8 is our range. Sometimes I'll put this little different parenthesis around it too, so don't get confused if they do that to you. All right, and you might even have a big capital R for range. All right, so that's all they're looking for. Domain is your input, it's your X values. RAR, or the range, is our outputs, it's our Y values. It's what happened after we put in the input. That's what we're looking for here. And then there's actually a third thing. Is the relation above a function? Remember a couple things times ago, we did that graph and we connected the dots, and if it passes the vertical line test, then we know we're good. Well, in this case, all you have to do is list all those input values again. Okay, list all the input values. So when we're trying to determine, is a relation a function? So in this case, if we list all the X values, we're going to end up with, well, let's see here. We're going to end up with 3, -5, 3 again, 0, and 6. Well, as we did that, the question becomes this. You just ask yourself, for the X's and only the X's, we don't care about the Y's, we don't care about the range when we're trying to determine if a relation is a function. All we care about is the domain. We care about the X's. After you list them, ask yourself this. Are there any duplicates? In this case, we said yes. And if you say yes, then you do not have a function. So it kind of feels like the opposite, right? But yes, there are duplicate X values, therefore we do not have a function. Okay, so keep that in mind. And beyond that, those are the big things you're going to work on. Also, remember when you're doing domain and range, if you're given a scenario, remember domain and range also may have restrictions or limits. If you have a restriction or limit, that's like the real world scenario. Okay, so make sure you think about, okay, although a function may go on forever, sometimes if the function is representing a real world scenario, like if we're looking at 24 hours in a day, X is the number of hours, we can't go beyond 24. We're into the next day. So there's a limit to your domain or range. So keep that in mind if you're asked one of those real world scenario questions and asked to find the domain and range or range of a scenario. Hope that helps.